Yeah, so I will be talking about a question today of InterviewBit, that is search in Bitonic array. The question is like that: given a Bitonic sequence A of n distinct elements, write a program to find a given element in Bitonic sequence in O of log n. And here the definition of Bitonic sequence: given a Bitonic sequence is a sequence of numbers which is first strictly increasing, and then after a point it is strictly decreasing. So what can we get inference from this is that Bitonic sequence is like this: you get a peak element, and all the elements before it is less than that element, and all the element after that is also less than that element. Okay, so it will be first increasing, and then after that, after we reach the peak element, it will be decreasing. And all the given it is that all the elements are distinct, so it will be strictly increasing and then strictly decreasing. So this is a Bitonic array. So n given 10 to the power 5, 3 to 10 to the power 5, ai given, like the elements of that array can be up to 10 to the power 8. So like what we need to find is that if a element b is given, we need to find whether it exists in that array or not. And if it exists, then we need to return its index. So the first thing is that if the array is given sorted, if we can sort the array, then we can easily find the whether the element b exists or not in that array using binary search. Is that okay? Like if the array is sorted, like if the array is 1, then 3, then 5, then 6, like that, then doing binary search, like low equals to, like keeping low equals to 0, then high equals to n minus 1, we can do binary search easily, and we can find whether an element exists in that array or not, and we can also get the index of that element, right? But here here the array is not sorted, it is Bitonic array. That means it is firstly increasing and then decreasing. So what I am saying is that if you can find this peak index, like where the peak element exists, where this peak element exists, if we can find that, then from 0 to that index, the array will be increasing, right? And from I to n minus 1, from index I to index n minus 1, the array will be decreasing. So what we will do, if we can find this peak element, then we can simply do a binary search here and a binary search in this part, right? And after doing binary search, we can first we'll do binary search in this part, and if we find that element, then we get the answer, and if not, then we'll do binary search in this part. If we'll find the element in this part, then answer will be that index. And if like we cannot find element in the both the part, then answer will be -1, that is element does not exist in that array, right? So what is our goal is that, is to find this peak element, right? Now like how we can find this peak element, and it is given that we need to find this peak element in O of log n. If it is O of n, then we can find we can easily find the peak of element by traversing the array. But it is not O of n. It is given that we need to solve this question in O of n. So we need to like do binary search for finding this peak element also. So now, how can we find this peak element, right? So like how can we find this peak element? What I'm going to do is that I will do a binary search, and what I will do in binary search, that uh, I will write the condition that what is the condition to find this element. There's a unique condition to find this element, that this element is greater than its left element also, and it is greater than its right element also, and this property is possessed by only this element, not any other element. If we consider any element here, then it's the element left to it will be lower than it, and element right to it will be greater than it. And if we consider any element at this side, then any element left to it will be greater than this element, and any element right to it will be lesser than this element. Okay, so what we need, like what we can do to do a binary search here is to get to manipulate this condition that ai is greater than ai minus 1 and ai is greater than ai plus 1. So I will show you the code how to find this peak element. Yeah, so initially I initialize low equals to 0, high equals to n minus 1, ठीक है, and index equals to minus 1 initially. While low is less than equals to high, mid equals to low plus high upon 2. See here, what I'm writing here is that if mid equals to 0 or array mid is greater than array mid minus 1 and mid equals to n minus 1 and array mid is greater than array mid plus 1, that is what I'm writing here is that if array array mid is greater than array mid minus 1 and array array mid is greater than mid plus 1, that is that array that mid element is greater than its left element and its right element. Then that is the that is the that peak element that we are trying to find, right? So the index will be that mid element and will just break. And I have written mid equals to 0 here because if if we encounter 0, then this mid minus 1 becomes minus 1 and indexing will fail, like you will get a runtime error. That's why I have written if mid equals to 0 or array mid greater than array mid minus 1. Similarly for mid and I've written mid n minus 1 here or this thing, because if array if mid equals to n minus 1, then mid plus 1 become n and it will again give you runtime error. So this is a good technique to write these things beforehand. Okay, so if this condition fails, then there can be two conditions. If this condition fails, that this implies that this the element can be in this region or the element can be in this region. If the element in this region, then array mid minus 1, that is array that is the array which is the element which is on the left side of array will be lesser than it, right? So I've written that condition only, bit is not equals to 0, like the same thing. And array greater than array mid minus 1, if array is greater than array mid minus 1, that is that means that we are in this region. Okay, we are in this region and peak element is right to it, so we need to upgrade the low, we need to upgrade the low. Okay, and else we are in this part, and for to reach here we need to decrease the high. Okay, so like this, in this way we find the index of the peak element. Now we have found the index of the peak element. Okay, we have found the index of the peak element. Now what we will do, we will do a binary search in this part, we'll do a binary search in this part, like because this is forward sorted, this is backward sorted. If we find the element in this part, then this will be the answer, and if we find the element in this part, then that will be the answer. If we do not find the element in either of the parts, then the answer will be minus 1, that we didn't find that part. uh, yes, since the array from 0 to index array from 0 to index is forward sorted, in increasing order, so I just used stl lower bound to find the whether this element exists or not. Yes. Okay, and since the other part of the array is backward sorted, like if it is a decreasing order, so I used binary search to get the whether this element is present or not. So I initialized low as index, high as n minus 1, low is less than equals to high, then I simply return I initialize mid equals to low plus high upon 2, like the simple binary search. And if we found the element b, array mid equals to b, then we return the mid element. And if array mid is greater than b, then we increase the low. And if array mid is less than b, less than equals to b, then we decrement the high. So if we get the element, we return a mid, and if we come out of the loop, this implies that we are not able to find that b element in this part also, so we return simply minus 1. I hope you this solution would have helped you and you have understood the solution. Thank you.